In today's video, we're going to go over naphthalene nomenclature. Naphthalene is a polycyclic aromatic hydrocarbon, and it has a unique numbering system. So with naphthalene is essentially two benzene rings, if you want to think about it that way, kind of put together. But you're going to start numbering from here. As such, all the way around. So when you put a substituent on one of these carbons, it depends on how many substituents you have and where it's located, where you're going to number from. And you notice that we don't number these two carbons here in the middle because they already have 4 bonds. So it's irrelevant to really number those. So how would you name some compounds that would be on here? So if I just draw another naphthalene structure real quick. Here. If we put a methyl group, say on the number 1 carbon, this would simply be 1-methyl naphthalene. So 1-methyl naphthalene. What if we put another methyl group on this? So if we put another methyl group, let's say at the 4 position, 1, 2, 3, 4. This will be now 1,4-dimethyl naphthalene. So remember, we start numbering here, and we can go all the way around. Now you might ask, what if we have a situation where the methyl group was on the opposite? My handwriting is much better on paper, I promise. Maybe not much better, but hey, we'll deal with it. What if we had the methyl group, say, down here by itself? Well, that too will be 1-methyl naphthalene because these molecules are symmetrical. If I would, say, rotate this naphthalene 180 degrees, this right here would now be on top. So it's the same molecule. It'll be the same way if I put the methyl group over here. This also will be 1-methyl naphthalene because, again, the whole compound is symmetrical. So you have to be careful with that on the test. If a professor tries to test you on that, just be aware that anywhere on these positions here can be a 1-methyl. If it's by itself, it can be a 1-methyl. Or if it has, let's draw another structure. So if I was to redraw this, like so. And if I put a methyl group, say on this carbon here, that would be 2-methyl naphthalene. And it's 2-methyl naphthalene because this would be the number 1 carbon. And if I put that over here, this also would be 2-methyl naphthalene because that would be the number 1 carbon. And if I put it here, this would also be, well, if I put it on here, rather, this would be 2-methyl naphthalene. because it would be the number one carbon. What if we did something like this? So what if we had a methyl group here, methyl group here, methyl group here, and a methyl group here? Well, we would start where we ran into the most number of substituents first. So in this situation, this right here would be the number one carbon. Number 2, 3, 4, 5, 6, 7, 8. Again, this right here is numbering always starts on this carbon here, and this carbon here can be either one of these carbons, but it's going to be relative to the compound itself because the compound is symmetrical, and it's going to be relative to the substituents that's on the compound. So how would we name this? So this is a methyl group here, and I'll go ahead and draw the methyls for it's a bit more clear. And this is a methyl group here. So we would name this 1, 2, 5, 7. Now this would be tetramethyl naphthalene. Tetramethyl naphthalene. Okay, so just know when you're doing naphthalene, this basic polycyclic aromatic hydrocarbon here, the numbering system is going to be like this, but it's going to be relative to the position of the methyl groups or ethyl groups. This can be an ethyl just as well as could a methyl group. And depending on where these groups are located, it's going to depend on how you're going to start numbering. And so if we did this compound here, this would simply be 4 ethyl, 1 methyl naphthalene. So even though the number, we went over this in organic 1, even though you're still going to number this 1, 2, 3, 4, we're going to have to alphabetize the names. So E comes before M, so it'd be 4 ethyl, 1 methyl naphthalene.